The biggest leaks that I've found, those are most often in areas that don't get wet, right? What I mean by that is like, under like an eyebrow, like that sticks out of the roof, like that roof to wall underside connection, did they seal that really well? Or like, just under a soffit somewhere, or like in a lot of these buildings have like underground parking garages, but there's a bunch of conditioned space that goes down into that garage. Like, did they seal all those penetrations that go through there? That's kind of where stuff gets missed. I think people are generally pretty good.
Hey there, Sam here with the Flow Lab. Before we begin, I want to tell you about a free ebook that we have called What If Houses Came with Manuals? It's a practical resource that shows you how to think about the whole house as a system and not just treating the symptoms. You'll learn about blower door testing, pressure diagnostics, and HVAC analysis. We're sure that this guide will level up your testing game. The link is in the description below.
Welcome to the Flow Lab, the podcast where we dive deep into the science of building performance and HVAC innovations. Today we bring you another insightful episode aimed to enhance your knowledge and expertise in the field. Joining us are your co-hosts, Ben Walker, co-CEO of Retrotec, and Sam Myers, a renowned building science specialist and Retrotec trainer. Together, they bring a wealth of experience and knowledge to ensure our discussions are both informative and engaging. So, sit back, relax, and get ready to enter the Flow Lab, where we'll explore the world of building performance. Let's get started.
No, it's cool. I just thought with, all your insight into large building testing and stuff, it'd be fun to talk about what kind of stuff you're up at ABAA these days and any kind of upcoming training courses that you guys are putting on, things like that and stuff. But when did you start with ABAA?
It's been just about a year now, slightly over a year that I made the transition over to ABAA. Before that, I was working at RDH Building Science, which is one of the larger building science, building enclosure consulting firms. Just here, I was out of the Seattle office, but they're all over the country. I was with them for a long time, and then of course, as you know, before I was at RDH, I actually was working at Retrotec. So,
yay!
Known Ben a long time. I think since like 2010 or something like that when I first started working for you guys.
It's crazy to think about how old we really are.
I know. Yeah. So Retrotec was like that was my first job out of college. So I was fresh as a daisy, not really knowing anything. And I learned a lot, and it was a really cool experience working there.
Oh yeah. That was great working with you.
Let's start at the beginning then. So like you said, that was your first job out of college. What was the appeal there? Like what kind of got you interested in airtightness testing?
Yeah, I feel like so many people in this industry I've talked to, I sort of like fell backwards accidentally into it. I can't claim that I graduated from college and I was like super psyched to go like learn about blower doors, like I didn't really even know what that was. But, I was looking for jobs after I graduated. I really wasn't sure what I wanted to do. And Retrotec had a job posting that I found and started researching it and sounded really interesting. The program I was in, I went to UBC actually up in Canada, in Vancouver. The program I was in was an engineering program. It's called integrated engineering. So it was a bit of a mix of civil and mechanical engineering. And I really initially wanted to like specialize in fluid dynamics, and maybe go into aerospace. That was kind of at one point in time, that was a career path I was looking at. But airflow measurement seemed like a really interesting thing to get into. And I really was always fascinated by the physics of fluid dynamics, and airflow measurement. It's certainly that's a big part of it. So I applied and, met with Colin Gange, and he hired me. Must have seen a twinkle in my eye or something he liked. But so then I was at Retrotec for, I think, a little over 3 years, kind of working on the engineering side, developing products, helped to work on the DM32, not the 32X. This is like, older.
Yeah, eons ago.
And working on Fantastic and some of the calibration stuff, and, doing a bit of training and, teaching people how to test even back then. But then I kind of wanted to get more involved in like the building science, as a whole, and not just focus on airtightness. So, I had worked some with RDH when I was at Retrotec, and they just seemed really sharp, and I, liked working with them. So I reached out, and, they were looking for people. So I moved down to Seattle and worked for RDH, just learning all about the building enclosure and building science in general for over a decade. I was there.
Oh, wow.
Yeah, I was going to ask if you had any, did you get any field experience while you were at Retrotec? Like, did you get to go out with customers or anything, or did that all really start after?
Honestly, very little. Yeah, I went out and did a few tests, and I would work with customers and get out there testing a little bit, but nothing like what I did at RDH, where we're doing tons of testing and working on tons of different buildings. I'd be actively working on 5 to 10 different buildings at a time, and so
Yeah.
you really it's kind of drinking from a fire hose in some respects, but you learn a lot really quickly. You learn about where things go wrong, and just how air barriers get screwed up, which is a lot of different ways.
Oh, yeah.
Yeah, what 2 parts, I guess, or how many large building tests do you think you've done, and then what's the largest one so far?
I don't have a number. I would guess it's probably it's in the hundreds. I would say probably between 200 and 300 if I had to guess. Large buildings I've tested.
Oh,
The
wow.
largest one by volume was just a giant warehouse. It really wasn't that exciting of a test. The tallest building I tested was, I think, 35 stories. Tested as a whole building. I've done guarded testing of chunks of floors on taller buildings, but tallest whole building test I've done, I think, was 35 stories, or might have had a penthouse 36th floor. So I don't remember. This was years ago, but somewhere around that neighborhood. Yeah.
How many fans did you have set up for the building? It was a shared corridor or something like that in the 36-story building?
Yeah. So for any kind of high-rise test, multi-floor test, you're mostly just relying on stairwells to transfer air from your fans to the rest of the building. So we had fans on a bunch of different floors. Yeah, we had some up at the roof. There was a roof deck kind of at level 8 or something like that. We had some fans there. We had some fans down at ground level. So you got fans kind of all over the building that are all interconnected. And, you got to get, a really important part of the test, as you guys know, is getting a uniform pressure throughout the building.
Yeah, exactly.
So you can't just jam all your fans on ground level and hope to pressurize the 35th floor. It's not going to happen.
Yeah, a lot of stories can provide a lot of opportunities for bottlenecks and things like that.
Oh, yeah. Yeah. It's you can actually calculate exactly how big the bottlenecks need to be, but there's sort of quicker, shorthand ways to figure that out that we've learned over the years. And we teach that in the ABAA training course.
Yeah. So since we're still talking about the buildings you tested, what's maybe the most interesting one you've tested, and one that just kind of really sticks with you that you use as an example a lot?
The most interesting ones, I would say, are the existing buildings, because there's so many unknowns. You really don't know what you're walking into. I think with new construction, generally a lot of the buildings I've tested were buildings that I've worked on through early stages of design. I've been out on site during construction. You kind of know. You almost can guess what the result's going to be. Not exactly, but if it's going to be tight, walking into it.
Yeah.
Or where the problems might be, if there are any, you already have a good sense of that. But with existing buildings where it's you just have no idea what's going to happen. There's plenty of stories I could tell, but
that's more fun on the forensic
with
side.
new construction, you have a target that you're shooting for, right? You're trying to pass a requirement. Yeah. With existing, you're probably there because there's some issue that's happening.
Exactly. Yeah. A lot of times with existing buildings, you're there just on a forensic mission. Basically, you're trying to figure out. You play detective. Figure out what's going wrong, and really got to use your brain a lot more to kind of think through what could be happening.
Sure.
Yeah, that's definitely.
They're always fun.
Yeah, it's a fun time.
So, where are the most common leaks found then in large buildings? Really, where's the problem areas?
Oh, are we talking new construction or existing, or I guess
let's do both. Let's start with new construction and then let's talk about existing.
A lot of times, the biggest leaks that I've found. There's leaks all over the place, but I would say the ones that are big holes that get missed, those are most often in areas that don't get wet. Right. What I mean by that is under an eyebrow that sticks out of the roof, that roof to wall underside connection. Did they seal that really well? Or just under a soffit somewhere, or in a lot of these buildings have underground parking garages, but there's a bunch of conditioned space that goes down into that garage. Did they seal all those penetrations that go through there? That's kind of where stuff gets missed. I think people are generally pretty good, although not always. They're pretty good about sealing up stuff that's going to get rained on, right? You don't have just constant, giant gaping holes in the roof, for example. But anywhere that's not going to ever get wet, that's where I think a lot of the big holes remain. that people just kind of forget about, that it's like, oh, it's, we don't really have to seal it that well because, no one's ever going to spray water on this. Like it's never going to get rained on, but it's still a hole in the air barrier.
Do you think some of that is probably due to, like, I know when we do trainings, we start with the plan review, like where's the air barrier, what's conditioned space, what isn't? And then a lot of large buildings, there's like a weird gray area that we have to figure out, is this inside or out? Do you think some of that just stems from that? Like they don't know if they're supposed to seal there or not?
Yeah, there's some of that's just confusion for sure. I think some of it's just, lack of detail from the architect, or sometimes it's just like stuff that gets missed just during construction. It's no one really thought about it. It just didn't happen. It was, a finger pointing. Someone thought it was in someone else's scope. And, I think, really, if I could break this down, I think a lot of the biggest problems just come from communication problems.
Yeah.
It's like somebody didn't have some piece of information, or they thought someone else was doing something, or at some point along the way, it's nothing like malicious. It wasn't like, they weren't trying. It's just there was some piece of information that wasn't communicated to the right person.
I think that's one thing that both commercial and residential share. Like that's one thing they have in common, is like whose responsibility is this to make this happen?
Off,
and then the finger pointing happens in both too. So
sure. Yeah.
So it's new construction. So what's different about existing buildings where you usually see the biggest leaks?
Existing buildings, I think it's going to so much depend on the construction type. Like if it's like just like a big like mass masonry wall, like multi-wide brick, that like the brick itself is probably not going to leak that much. I would be looking at, again, like any of those soffit transitions, roof to walls. I would look around windows. The windows probably all leak pretty bad unless they've been retrofitted. You're looking at, there's going to be a ton of leakage through mechanical systems, not just through the system itself, but like through where ducts penetrate the wall or, go through the roof. There's going to be some leaks there probably. For, like a wood framed, mid-rise building, like an old apartment building from like the 80s or something. I mean, yeah, it's probably going to leak at all the rim joists, at the base of wall, probably around windows, at parapets. Yeah, especially anything with like a vented roof. That roof to wall connection is just really tricky to transition at the roof line. That's going to be a big source of leak. I've tested very few vented roofs that were super tight. There's almost always going to be some leaks there. But yeah, it depends on the building type, where I might look for leaks. There's all sorts of different types of buildings with different characteristics that are going to perform differently.
Ever tried to test a building that the stack effect was like so bad that like you couldn't even, it's like practically impossible to try to test the building, or you somehow always managed to get around it?
I haven't actually gotten to the point where I tried that. Those are some of the buildings where, we ended up doing guarded testing, floor by floor instead, because we were very concerned, like, that the building was so tall and we wouldn't be able to overcome the stack. So that's
one way around
testing a big building like that. There's a huge amount of planning and coordination that goes in up front. And it's not like you can't really shift gears like that last minute. Like you can't get to the point where like the whole building's prepped, you've set up all your equipment, and now all of a sudden, oh crap, we can't test this building because there's too much stack. Like, at that point, that's a major change that you should have planned for ahead of time. Like it's, it's like some of those buildings I've tested that were, 40 plus stories. I've just done guarded testing floor by floor. And we didn't really
still do like the top and the bottom and some sampling, or just the sampling?
Yeah. So, I mean, these were all in Seattle. So, I mean, that procedure is not explicitly allowed in code at all. It's not referenced anywhere. So we basically worked with the city. We worked with SDCI. We submitted a code variance request saying, hey, like, we don't think it's practical to test the whole building for these reasons. Just kind of explained our case and justified it. And then we came up with a sampling protocol, which was we were going to test, the bottom floor, the top floor, and then any other floors where it changes significantly. So like, there's like a podium and then a tower on top. We would test that transition. And then for common floors that are just the same going up a tower, we would just test, every 10 floors, a common floor would test that. So that was kind of our sampling protocol. And then the city came back and they wanted us to do 2 floor chunks at a time. because they wanted to make sure we were capturing that floor to floor joint properly, that stack joint in the curtain wall system. And so we basically did chunks of 2 floors, simultaneously going up the building.
Yeah, that makes sense.
So yeah, we worked with the code officials to kind of come up with a protocol that seemed reasonable, and then just ran those tests, and we got decent results. The building passed. It was quite tight. So yeah, so that's what we did.
Cool.
But that was definitely more of a ask for permission rather than forgiveness kind of a scenario.
Yeah, sure. It's a smarter play that way.
When you do the sampling, like when you test like a couple of floors, like what's your method for sealing, isolating those floors off from the rest of the building when you do the test?
The buildings that I've done this on, and this is pretty typical for high rise, like they've got a really big, like just thick concrete core in the center of the building, and that's where the stairwells run up through. And so we ended up kind of isolated that whole central core, and that's where most of the shafts run through. So we just kind of like sealed that off from the rest of the floor, and just put our fans in the stairwells to draw outside air through the stairwells. Yeah, so we had to like seal off the elevators, seal off those shafts, but yeah, it was all kind of contained mostly in that central core, which has made it easier. But yeah, there's a lot of coordination to get that done, and working with the contractor on site to make sure that they can get off the elevator on those floors, have signage posted, because there are people working in the building while we were doing this, just on other floors.
Sure.
It's a huge high-rise building, so we just kind of closed off those floors we were testing and ran with it.
And do you guys usually do that prep work yourself, or do you let the contractor do it and then inspect it?
Almost always we would let the contractor do it and we would inspect it. There were a few times, I've done quite a bit of taping, more than I care to, but
always bring extra.
Yeah. Well, and it's like, I mean, was an engineer working for a consulting firm, like putting on tape and plastic, like billing it, crazy high rates. Like it's in everyone's best interest to use cheaper labor for that kind of stuff.
Sure.
Like it's not efficient to pay my hourly billing rate to tape, exhaust fans, but not to say I haven't done quite a lot of it. So yeah.
Then would the tests take multiple days, or you usually try to get in and out within a shorter period of time than that, or just varies?
So yeah, if we're testing a whole building, it's in and out in a day. If we're doing like the floor by floor testing, we came back multiple times because we were testing as they were building the building going up. So we couldn't really test the whole, all of those at once. But yeah, if it's a whole building test, in and out in a day. That's pretty standard. You just bring as many people as you need to get that done.
Yeah, while you were working at Retrotec, who was your favorite person to work with? I'm just kidding.
Of course,
I think we know.
You, Ben.
Yeah, so then at ABAA now, you're like one of the lead trainers, and then that's what you're training on, is mostly like airtightness testing on large buildings and things like that these days.
Yeah, so I mean, my role is technical director, but I do lead the whole building airtightness training program, among other things. But yeah, that's been a big push since I started to kind of expand that program nationally. So that was actually, there's a lot of history there with that program. ABAA was kind of, there were a lot of code officials and, people wondering like, well, if we're going to start requiring, testing these large commercial buildings in a, on a code level, like a national level, how do we know that there's, people that can do this kind of testing and that are qualified, that are trained to do it? That was sort of a question mark that that ABAA would get a lot from code officials is, how do we know that there's enough people that can even do this? And so it's kind of a, do you put the cart before the horse, or how do you tackle that? Because it's really like a lot of people are not going to bother to get certified until the testing is actually required.
Yeah.
Right. And so I think ABAA just decided to take the first step and just say, all right, we'll come up with a certification program, a training program. It's all ISO 17024 like accredited. It's it's a really intensive certification process.
It's a week-long course, right?
It's a full week-long training program, and on top of that, then you still have to pass exams to get certified. ABAA actually hired RDH to develop that curriculum to develop the training program. And so I was working on that, for years when I was at RDH, developing all the training materials, the PowerPoints, the training manual, all the different exercises and activities and all that. I mean, you guys know, put on training. It's a lot of work to put that all together. So RDH developed that for ABAA. I was one of the leads on that project. And now I have to live with all the training materials we put together because I got to go teach it. No, it's been great. So I've been teaching the class. I've been training other instructors as well. We initially rolled out the training course in Seattle. We're working with South Seattle College locally here, which is great. We basically just rent out a space from them. And the coolest part of the program is the final day of the class. We actually have all the students test a real building.
Yeah, that's awesome.
So it's, we test one of the buildings on the South Seattle College campus. And we go through a whole week of training. And then the final day is, we have the students kind of in groups rotate through and test that building kind of on their own. I mean, we have, instructors there to make sure like they're doing it correctly, but it's really like the students are running the whole show on that final day, which is great. It's been a really, really valuable part of the program. So we've been doing that in Seattle since 2022. And then we've just last year, we opened a new facility down in Florida, actually in Daytona Beach. And that's through Salas O'Brien has a facility down there. So we run the course out of their facility, and then we can actually test their whole building that they're in.
Oh, yeah.
Which is great. So we have another building down there that we can have students test. And again, that final day, they just kind of run through and test that building and have to work through any problems they run into. We're now weeks away. No, I'm not even 2 weeks away from opening our third facility in Chicago. Yeah. So we got a class coming up. Yeah.
Yeah. The Windy City, you get to test out those bias pressures and everything then.
Yeah. So it's only a 2-story building that we're testing, but it's a pretty big building. So we're testing that as part of it. So yeah, super excited. And then we're trying to expand it to other markets as well. Still don't have any facilities in the Northeast. So that's really a priority. We've been talking to some folks down in Texas as well to get something going down there. But yeah, we've had a lot of interest in the program. It's been really cool. I've been, trying to get other instructors up to speed. It's been a fun process to see that come.
Talk about the certification a little bit. So like what do students actually get once they kind of go through and take the training and pass the exam?
Yeah, so we're already starting to see references to the certification. I've seen it in some Army Corps of Engineers specs. If you're doing that kind of testing, they want a certified person to be doing it. It's already referenced in the Washington State Energy Code. The new IECC has some language about it has to be a qualified third party, and so that's it's kind of. It's up to the code official what qualified means, but they may ask for some sort of proof of training or certification. So yeah, we're starting to see people talk about it. It's to become certified, there's a number of different pathways to do it. You actually don't have to take the training course because we recognize that there's a lot of people in the industry that already have been doing this kind of testing for many years. They already are very well qualified. If they want to pursue that certification, they still have to pass the exam, but they don't need to take the training.
Oh, interesting.
But then we want to make sure they have some level of practical experience. So if you're, I can pull up there's a whole infographic on our website about it. But basically, if you haven't done the ABAA training, you have to jump through more hoops to get certified. You have to submit test reports from real buildings that you've tested. And we'll review those reports and make sure that you know what you're doing and you can do a decent report.
And it has an ISO certification, doesn't it?
Yes, yeah, it is a ISO accredited certification program. Yeah, it's the only one as far as I'm aware that is ISO accredited for air leakage testing.
Cool.
Is there a particular spot that someone needs to go to on the ABAA website to find out about upcoming trainings and the costs and everything and to sign up and stuff?
Yeah. I mean, if you just go to the, airbarrier.org, that's the ABAA website, And if there's just on the homepage under programs, you'll see the whole building airtightness program. You can do that. I think it's listed there. Or I think if you go to the events menu, they're under training courses. It'll show up there as well. You can see all of our upcoming training courses. So not just whole building, but installer training and field auditor training, that sort of thing. But yeah, any of those, it'll take you to the same page. So yeah, our next course is coming up in June. We actually have 2 of these in June. We've got one in Seattle and one in Florida.
Wow.
That you can sign up.
You guys are busy.
Yeah. So,
and do you go to each one and teach, or you're, like you said, you're teaching other instructors?
I have been going to each one, but the goal long term is to have other instructors take over. Once they're fully up to speed. So yeah, the training course is not manufacturer specific. So I know I'm on a Retrotec podcast, but we also train to the Energy Conservatory equipment and software as well. So you can learn either one. Our philosophy is it's sort of like. It's like a driver's ed course. Like we're teaching you how to drive a car, right? Whether you want to drive a Chevy or a Honda or whatever, yes, they have different features, and yes, people have very strong opinions about
one or the other.
What kind of car they like. But at the end of the day, like we're trying to teach you how to drive correctly. So that's the goal of the course. Like
I appreciate it. Yeah,
that's what we're trying to focus on.
So you can tell through all the coursework and everything, a lot of neutrality on all that stuff, but just the basic concepts and everything, trying to come through.
It's something the industry's needed for a while, because large building testing has just kind of been the Wild West. It has been what it has been, and we just have to, take whatever result and just kind of assume they knew what they were doing.
Yeah. So our goal is to make it not that. We want to get people trained who really know how to do this properly. They're not going to cut corners or make mistakes, or they need to know all the intricacies of how pressure and airflow works in buildings, and how to use the equipment and software correctly, and just how to troubleshoot any issues that come up.
Yeah. What are like some of the most common mistakes that you see kind of people making in the beginning, really?
Yeah. So I've seen a lot of people make mistakes with both interior and exterior tubing, your reference pressures, all sorts of dumb stuff. I mean, I've seen people, so like for Retrotec, you guys, the blue tube is like your internal reference tube. So that's where you can tell if your pressure is the same on level 27 as it is on level 1, right? Relative to outdoors. Like you want to make sure that's uniform throughout the building. I've seen people, they'll take 2 gauges with 2 different blue ports, and then they'll tee those tubes together and then run them up to different floors. And it's like you're averaging those pressures. Of course, they're going to be
just averaging them together.
It's all the same.
Like stuff like that, where it's like that's really dumb.
These are the same. We're good.
Yeah, like of course it's going to be balanced if you like manifold the tubes together. I've seen people try to measure exterior envelope pressures like at the bottom of the building and at the top of the building, and then they can't figure out why their pressures are not uniform. It's because the stack effect is you're never going to get that uniform.
Yeah.
Like it's not.
Yeah.
You like your exterior envelope pressures have to cross the building all at grade. You should not be measuring them out at the top of the building. I mean, this is all stuff we go over in class, but like I've seen people mess that up all the time. And it's like, you can sort of get away with it if it's like a short building where the stack effect isn't that large, or if you've got like a, perfectly like good weather where it's, you get the same temperature inside and outside. So your stack effect is again, really small. There's kind of ways where you can sort of get away with that, and it's not that big of a deal, but it's really like, it's not good practice. It's not what the test standards say to do, but I've seen people do it. And so, yeah, tubing stuff for sure is a problem.
Yeah, stepping on them, pinched, stuff like that.
And so the test standard that you guys are really pushing is ASTM E3158.
Yes.
Why is that? Why has there been a need for that standard?
The test standards were written, back in like the 80s or the 90s, and they were written for testing single family homes, right? That was their intended purpose. Like that's what, ASTM E779 or E1827 or so many of these standards were written for single family homes, and that's kind of what they were meant for. They talk about like vacuuming up ashes in the fireplace. Like, there's like, it's so clearly written for a house, and people have kind of adapted them to sort of work for large buildings. But there's not a lot of guidance for like how to prep the building, They don't really talk all that much about like where you should measure pressure uniformity and why it makes sense. They don't talk about like multi-zone buildings where you've got separate occupancies you're trying to balance pressures in. There's not a ton of information about how to handle those situations. That this is the kind of stuff that comes up all the time in large buildings. So never mind like the actual data you're getting, like E779 wants you to test down at 10 pascals. Like good luck getting a stable reading at 10 pascals in a large building. It's impossible.
Even in a house sometimes it's tough.
Like it's so the Army Corps of Engineers, I got to give them a lot of credit. They were the first ones to realize like this is a problem. And so, they developed, along with ABAA and many other industry experts, including people at Retrotec, they developed their test protocol, the Army Corps of Engineers air leakage test protocol. I think it was first released in like 2010, and then they updated it in 2012. That was actually meant for large buildings because the Army Corps was requiring testing in all their buildings. So a large like Army barracks and things like that. So it was, they tested at much higher pressures. They tested for longer periods of time. They had more guidance about how to prep mechanical systems. But like all the underlying math, like all the data analysis and all that, it's exactly the same as ASTM E779. They just copied and pasted all the formulas. So that all makes sense. But then that was really still not like, it didn't address a lot of other common issues. So again, ABAA got together and helped write their own air leakage test protocol. Their I forget what the name of it is, but they basically came up with this test standard that had a lot more guidance. It had all these appendices with like helpful tips about how to do the test properly, all sorts of different scenarios. But it was essentially written for a large, like complicated multi-zone building. And then, so that was then adapted. The ABAA standard was adapted into ASTM language, and that became 3158, which was first published in 2018. So it's not that old of a standard. So it offers a ton of guidance for how to test large buildings. It has guidance for how to deal with bad weather. So what do how can you accommodate like high winds or extreme stack effects? Like what do you do? And it's, gives you a lot more flexibility in test day conditions, how to deal with mechanical systems, all that stuff. It's the premier standard on air leakage testing as far as I'm concerned. It's really the most complete document. There's a ton of work that went into creating it. And it's also the only one of these standards that actually went through round robin repeatability testing. So back when it was first in development, there was a group, I think it was through ASHRAE, that actually took like, 10 or 12 like different companies with different equipment. There's a number of different companies, different manufacturer, like, some use Retrotec, some use TEC. There's all different equipment, different people, different days, and went through and tested the same building using this procedure over and over and over again to see like how close are the results getting. And it was super close. I don't remember the exact number. I have to pull up the study, but it's a very repeatable test method. It's the only one that's actually gone through that kind of repeatability study. So it's
wow.
Yeah,
that's awesome.
So
it's like a one size fits all.
Exactly. You can
kind of make anything fit
any kind of building with it, and it is actually now referenced in both IECC and ASHRAE. We're starting to see it, creep into other local codes as well. I mean, ideally it would just replace E779 or 1827, like these other ASTM standards that are kind of outdated, I think, and not quite. I mean, they still work for some building types and some weather conditions. Like, don't get me wrong, like it's not like they're complete garbage, but they're not nearly the same in terms of usefulness as 3158. So
sure,
I think the industry is going to be shifting toward that in the future.
Cool.
Oh, that's great. What when you're testing that building stock and stuff, like the new construction versus existing construction, and like in general terms, how did the results look most of the time as far as like possibility of these buildings? And
so
have we been improving over time? Or
I should just clarify that I would say probably 90% of the buildings I've tested were buildings that RDH was involved with as a consultant, and so that's going to skew the results quite a bit, right? Like we're making sure that the design is adequate before we're even going in. So I will say from that experience, yeah, everything is passing. Like it's really like the codes are set, I think, at a quite reasonable level.
Achievable level, yeah.
Like so I think IECC is now, what is it, like 0.35 CFM per square foot in the 2024. I should probably have that memorized, but I'm pretty sure that's it. Yeah, and I think ASHRAE is the same. And it's like, man, if you can't hit 0.35 in a new building, like you got to do better. Like that's not that hard.
You just got to try a little bit.
It's really not that hard. I mean, like we're not, even like the buildings that RDH was consulting on, like it's not like we're doing anything crazy, and we're still using like house wrap on a lot of these. Like it's not any like super expensive materials. We're not, coating the whole building in like some, super high end products or anything like that. It's, like you just have to try like a little bit and, don't like, make sure everything's like taped up that needs to be. I mean, it's really.
Yeah. And you have like assembly mock-ups on site and stuff all the time for people to follow for.
Yeah. I mean, that's certainly best practice, but honestly, like that's not every job. Like we're still passing these tests like with no mock-up. Like it's, again, like you definitely will benefit from doing a mock-up. I don't have the results compiled, but I'm sure that there's probably a trend that projects that do mock-up would do better on the whole building test.
Probably
but it's
so.
Still, like these are not like, people should not be like terrified of passing these tests. Like you have to try a little bit. Like it's really going to separate, the really crappy contractors from like the decent ones. So
man, awesome.
Yeah.
But then like the existing stock's probably like all over the place. Probably have like the existing stock that you tested probably just all over the map.
Yeah. And like some are not as bad as you would think. I've tested old buildings that like, do they even have an air barrier? Like who knows? It's like brick buildings from the 80s. Like how well did they seal things? And you test it, and it's actually like, wow, this is, it's not horrible. Like I think we tested, I'm thinking of one in particular we tested in Seattle. It was like just an old, just like brick office building from, I think like the late 70s or early 80s. And it was like, I think it was like 0.32 or something like that CFM per square foot. Like it's like, yeah, there's definitely some holes there for sure, but it's not like horrendous. So I don't know. You get all over the map though. I've also tested some buildings where like you can't even really get pressure because there's just so much leakage in an existing building. Those are usually the ones where it's like a forensic issue where it's like something is going horribly wrong and you have to go find it and fix it. So yeah.
Oh man.
I know one of the biggest issues that we kind of fight uphill with is when builders kind of bring a consultant, a large building tester on at the last minute instead of working with them at the beginning. Do you see any improvement with that at all today?
That's a good question. I mean, I'm coming at it from like a consulting perspective. Like that's where I was for the last decade. So generally we would be involved pretty early, but yeah, occasionally there would be like some project where they didn't realize for some reason that they had to test and they bring us in last minute. And some of those actually are decently tight. Some of them are not at all. It's kind of, you're just sort of rolling the dice at that point.
Yeah.
But
because at that point, it's just pretty expensive to go back and tear stuff apart and redo it.
Yeah. I mean, I like to say that, the whole building test is kind of like the final exam. It's like, if you've done all your homework and you've studied for the test, like you should do well on it. But if you're just like all of a sudden realizing like, oh no, like I haven't done anything all semester and I've got to like cram the night before, I mean, like you're in a way worse spot.
That rings a bell with me, really. Like
yeah. Me too, honestly, but
not a good idea still.
Yeah. So, I mean, you
can't dial down the center.
Like in that analogy, it's like the studying and the homework that's sort of like the drawing review, the field inspections, the mock-up, like all the kind of like quality assurance measures that should be taken, throughout the project should make it so that the final exam goes well, hopefully, because really like if you get to the final exam and there's just like systemic problems like everywhere,
it's too late by then,
it's
right?
kind of too late.
Yeah.
Right. Yeah. Like if like, okay, if they forgot like the detail, like this part of a soffit or something, like, all right, maybe you can get up there and pull a couple of panels down and get back in there and seal it like in like a discrete location. But if it's like just wholesale, like they screwed up everything, it's sort of too little too late at that point. Like it's really, you gotta be thinking about it all the way through.
Cool. So 10 years from now, where do you think commercial building performance will be?
Man, that's a good question.
Hard to predict, but maybe.
I honestly,
I mean, just the way things are trending now. I mean, we're I feel like we're getting there with baby steps. We now have a certification that's legitimate that people can.
There have been baby steps the whole way through my career. So I mean, it's definitely trending toward tighter buildings and better quality buildings. I think, but the progress has honestly been pretty slow and sort of disappointing in a lot of ways. Like, I mean. So just, you guys know this, but just for some background, like the state of Washington has had mandatory airtightness testing since the 2009 Energy Code, with very few exceptions in building types. So we've been testing essentially every new building in Washington since like the 2009 code cycle. And, we were like, Washington was the first state to implement that. And I would have thought like, okay, we're the guinea pigs. We'll figure all this out, and then other states will follow suit once they realize that, hey, this actually isn't that big of a deal, right? We figured out how to test. Yes, we definitely had some bumps along the way. We definitely learned some lessons the hard way. But it really it didn't slow down construction at all. It wasn't really that, it didn't give people that much heartburn. Like we started passing these tests immediately, and we've gotten better and better at it. And I would have thought other states would see that as a model and say, oh wow, like this actually like is valuable, like we're getting tighter buildings, and start implementing it. I would have thought that would have happened, a decade ago.
Sure.
But that's been really slow. We are starting to see a bunch of other states adopt airtightness testing, but there's always like, for buildings of a certain size or certain occupancy type, you don't have to. Or there's like an exception. There's all sorts of like exceptions or stuff built in where people can get out of it. For some buildings, they can get out of it. Now we're actually seeing in the new codes, there's quite a few buildings that actually will be required to, they have to actually do the test. There's no way around it, which is great. But it's not everywhere. It's hopefully we'll start to see more and more of that though.
Yeah. Well, I think the fact that the industry now has a place where they can go get certified.
For sure.
And it be legitimate is a huge step forward.
Yeah.
So we definitely appreciate what you all have done to make that happen.
Yeah.
Yeah, definitely.
Yeah. No, we've gotten a lot of good feedback from the attendees of the training, and it's been really successful so far. So
it's been good
really
for us
exciting.
just to send people in your direction when they ask.
Yeah.
It's like,
yeah.
How do I get certified? Because in residential we have options, right? In commercial
Sure.
we've never had that. So yeah.
No, we appreciate you having on, Denali. I know that Friday afternoon. I know Sam's probably ready to start his weekend like that.
You're on Eastern time, right?
Yeah. And I'm happy to have heard you pronounce it ABBA, because that means I've been pronouncing it correctly, because I've heard people say ABA and ABBA. So,
I know, I was actually a little bit nervous.
I've heard all three. I think I've probably said all three actually at various points in my career. So yeah.
Wasn't sure if ABBA was okay or ABAA.
I don't know. ABBA. I think ABBA is sort of trying to distance us from like the Swedish pop band.
Yeah, I know. They said you need to use one of their songs as like a theme song or something like that when you start.
It's been done.
Just lean into it.
Yeah.
Again, it's been fantastic. I know.
You had some other question about common pitfall. I think we just kind of gotcha moments during testing that even experienced people fall prey to. I got some good examples there.
Let's hear it.
I think what really separates a good tester from kind of a novice is how good you are at troubleshooting.
Yeah,
which I think is it's its own skill set in a way. It's like it's really its own mindset that you have to think through things logically. And I've definitely like screwed this up before, but it's like you got to start with like what is the most obvious explanation for what could be happening, and then kind of work your way out into the more obscure things.
Yeah.
There has to sort of be like a process you go through. And we talk about this in the training course as well, but like, okay, what happens if like, you're cranking through the test and then, or like, this is a really common scenario where like you get everything set up, the building's all prepped, like all your fans are ready to go. and you turn on all your fans, you like blast them up to like 50% speed, and you're getting 10 pascals in the building, right? What's your next step, right? What do you do at that point where you don't even necessarily have line of sight, you can't see or hear your fans running or not? So like, what's the first thing you do? And the temptation is like, oh, we must have like left the door open somewhere. We must have like, there's some big hole in the building, right? So you just go running around looking for it. But like, what can really often happen is like, all right, someone actually didn't plug in some of your fans, right? So you don't actually, your fans aren't all running, even though you're connected to all the gauges. Like maybe you're not getting pressure because, only one or two of your fans are actually turned on. Or like they plugged it in, but they didn't flip the power switch. Or they didn't connect the, Ethernet cable to that. Like, just there's so many other things like you can check first before you start running floor to floor, like trying to figure out, is there a door open? Which I have done, and then realized, oh, my fans are actually off, and that's embarrassing. But yeah, just like that troubleshooting skill set, and there's so many different things that can go wrong during one of these big tests, is like just logically progressing through like, okay, what could this possibly be? Let's rule out the obvious stuff before we start like go running around looking for leaks. Like make sure all your equipment's still working the same way you think it should be, and just work your way out from there. That's a lesson I've learned a number of times.
But the hard way, yeah.
Yeah. I've been on the phone with testers multiple times where the answer was, "Oh, I thought I flipped the power switch on."
Yeah.
There's just like you can feel the embarrassment over the phone.
Oh yeah.
Like, all right, thanks.
Yep. Yeah. So just that, and a lot of that just comes from experience too. Like just you've seen a lot of stuff go wrong, so you kind of know what it looks like. You can quickly narrow down like what the problem might be. It just sometimes you have to learn those lessons the hard way. But I feel like I always learn something new on every test, it seems like.
Oh yeah. Especially in large buildings, especially the existing ones where there's always something weird happening.
For sure.
It's like they all have their own unique story.
Yeah. Or there's like some, mechanical system with an exhaust fan running in some corner of the building that you didn't know about because no one told you it was on, so you're getting weird numbers all of a sudden. Or I've had all sorts of weird things happen where, stuff kicks on that's on a schedule on the mechanical system that like even the operations staff didn't know about. They're like, no, we swear we turned everything off. And turns out, no, they didn't. Just I've developed trust issues. Like I just,
trust but verify.
Exactly. Trust but verify. Like how many times I've been told, oh, that damper is closed for sure. And you go look at it like, no, it's absolutely not. Yeah. You learn to just look at all that stuff. And yeah, it's fun though. I enjoy it. It's a fun process to.
One of my first large building testing experiences where I was kind of on my own was at a Walmart Supercenter. Three banks of fans, whatever. And at the end of it, I thought, I should have brought a bike.
Yeah.
Just trying to get around, trying to connect everything, test. And then
you mean they didn't have them on the shelves yet?
Yeah, not yet. Yeah. No, it's empty at the time.
Yeah.
Then we installed way more fans than we needed to, right? So like we calculated how many we may need and then ended up really not needing half of what we brought, and we'd set them all
That's
up
a good
anyway.
Sign.
Yeah, it was awesome. The building performed really well, but
we learned the hard way just how much it sucks to not test a high-rise building without an elevator.
Oh man,
there was one test we did. I think it was only like 13 stories or something, but that's still like the elevator didn't work the day of our test.
Man.
So we had to haul fans up to the roof, and that was brutal. So we literally like the next day we started adding that to our contracts. We're like, you shall provide an operational elevator on test day. Like, otherwise our price is going up. Like that's
Get your workout in though.
Seriously, I was pretty sore after that, but just stuff like that. You learn those lessons sometimes, the hard way, but
sometimes you use the elevator shaft to distribute the air too, don't you? Like close it.
I have, I've done that a few times. It's a pretty big safety hazard, so we've had to work with the contractor. They basically have to build temporary barricades across the elevator doors. We one time the elevator company insisted that they had someone monitoring that barrier at every floor that was open, so they had a physical person there at the barricade. Just getting paid time and a half or double time to stand there. But yeah, no, it's definitely something you got to coordinate ahead of time. You can't just start open up elevator shafts like midway through a test. Like there has to be a plan. There's got to be a safety plan for that. But yeah, it can be done.
Yeah, awesome. Well, thanks, Denali. Thanks for joining us and everything, and look forward to the training. I hope to get back down to Seattle one of these points. Keep sending Alex down there.
Oh yeah, no, it's been a lot of fun. So I think I'm also going to eventually turn this training course into another like research paper, like repeatability study, because we're testing these buildings, with different people, different times a year, with different equipment sets, and we're getting results that are, I mean, it's like, within 5%, of each other.
Wow.
for all of them. It's been really cool. So, done some of them in winter, some in summer, different weather conditions. Yeah, it's been really cool to see like how well the data lines up. So
that's awesome. It's encouraging,
I'll compile all that into a paper and, publish it for, ASHRAE or something like that. But yeah, that'll be cool in the future to get that all together.
So for anyone listening that wants to get certified in large building testing, how do they find out more?
You should go to our website, so airbarrier.org, and there's a whole page on it. So
also, we'll add the links to in the upcoming training sessions and the show
Yeah,
notes and all that stuff
for sure.
Yeah, for sure.
So
and then your LinkedIn and Instagram profiles and stuff we'll put on there too, whatever.
Yeah. Awesome.
Cool. Well, yeah, appreciate you spending the time with us. This has been fun.
Absolutely. Yeah. Good to talk to you guys. And really appreciate all your support with the, supporting the training program. I know you guys have been to pretty much every single one of our classes so far, which has been awesome. Both you guys and TEC have been very supportive, which is really what we want to see, the industry kind of come together. Like it doesn't help anybody if people are out there doing the testing incorrectly. So
right.
Yeah,
exactly.
We can all get behind, training and getting people doing the testing the right way. It helps everyone in the end. So really happy to have you guys on board with that. And pleasure to talk to you.
Yeah.
Happy to do so, man. Yeah, appreciate it.
Yeah. And you have the conference coming up.
We do,
next month too. So we'll see you there.
I think it's not too late to sign up. If anyone listening wants to hang out in Denver, it's a really good time. A lot of great speakers lined up, learning all about not just air barriers, but just the building enclosure in general. There's a lot of good networking opportunities. I think it's too late to get the early bird discount to sign up. You have to pay full price now, but
it happens every year. So if you miss it this year, it'll be back around.
It's in Denver this year. We changed the venue around. So come out to Denver this year in May, or if not, we'll see you next year.
Yeah, awesome. Well, thanks everybody.